write really interesting, programs, right, that can use pattern matching for our logic. So what does this kind of look like a little bit more specifically? So let's take like this hash here, for example, right? We've got a hash here, we've got a ship, Serenity, and we've got some crewmates, right? Now, the syntax, right, is what you're kind of used to. You've got a hash on the outer edge, you've got an array for the crew, and for each of the crew members, right, it's just another hash within that array. And we can see that through the syntax of using braces, in this case, brackets, sorry. And then we can also notice that each name of the crew members has a symbol for a name, and then each of the values are strings. Now, I'll get into that a little bit more as we get deeper into this, but it's a nice way. There's actually, what I'm trying to show here is there's actually a pattern to all of this, right? And we can use that to leverage that capability with pattern matching in Ruby. So some of the alternatives that we have today, which is conditional logic, right? This is what you're used to. You'll use like if, else, and you'll use case, when, else statements. And so that's been fine. But you can also use regular expressions, right? Regular expressions are another way to kind of do sort of like pattern matching and diagnostics within our code. But regular expressions can get kind of heavy and kind of ugly after a while too. So you want to be careful with those. And then lastly, you can use parsers, for instance, in Ruby, right? Because the Ruby parser, when it parses the code, actually breaks that down into an abstract syntax tree, an AST. And you can use Ripper or parser as those gems to actually break apart that code and look for patterns as well. So there's several alternatives that we have prior to actually getting pattern matching. Now, at the top, some of the things I want to cover in the pattern matching today is all this various syntax that we get in Ruby 3 now. So the syntax for standalone is using hash rockets and in. We can match on arrays. We can match on hashes. We can also match on the remainders of arrays and hashes using this kind of remainder syntax, splat and double splat syntax. We can also find things. We can also deal with void matching. We can do variable binding. We can do combinations. So conditional logic in our pattern matching using the pipe operator. We can use guard clauses, which you're used to in Ruby already, but we can actually bring that into pattern matching. And then the other cool thing is we can teach our objects, our non-primitive objects, to basically deconstruct themselves for pattern matching purposes. So I'm going to cover all that in today's presentation, and we'll dive into each one of those so you get a little bit more familiar. So the first thing I want to start out with is standalone syntax. Now, this is experimental even in Ruby 3. I'm going to show this initially. Don't worry about all the syntax because we'll get into this more as we get deeper into these slides. But it is experimental. And the way it works is you'll have two types of expressions. So in the first case, you'll use in, and that basically gives you back, you'll type in your expression, and then you'll give it a pattern in, and you'll get back either a true or false, a Boolean. In the second situation, you can actually do assignment using standalone syntax. So what does this look like? Well, if we look at standalone syntax here, where we have this hash, right? We have a character, we have a hash, and then we're going to use the pattern match here. We're just going to match on what looks kind of like a hash, right? But notice that this isn't, this is pattern matching syntax here. It kind of feels like dealing with hashes like you've always done in Ruby. But notice the difference here where we're matching on keys and structure. We're not looking at the actual values of the hash in this case. So we're kind of using a hash-like syntax to match to provide a pattern. And so when that gets evaluated through the hash rocket, what this does is it says, hey, look, the last name is Reynolds in this case. I'm going to put that value into last name, and then I can print this out down below. So when I use a put statement here, we'll see that it prints out last name and displays Reynolds, right? Pretty cool. Now, don't worry about all of this just yet. I'm going to dive into this more and explain this a little bit better as we get going. But the second aspect of this is standalone syntax using in. So in the first case, right, I was assigning a value in my Ruby pattern matching code. In the second case, I'm actually going to evaluate a true false. So the way this works is I have a basket of fruit, right? And each one of those in this array is a hash, and it has a kind and a quantity. Then I'm going to come down through my basket and I'm going to say, hey, does any of these actually have a fruit using the in syntax in this case, right, does it actually match this pattern, which has a regular expression of app? So what does that evaluate to? It actually evaluates to true. And the reason that happens is because Apple matches the APP regular expression. So that's true. In the case of peach, it's actually false. But since I'm using the any enumerable method, it comes back true because I'm just, as long as anything in that basket matches, I'm totally cool. So this is another cool way to use pattern matching to get to do a single line evaluation like that in standalone syntax. Now, again, I just want to emphasize this is really cool, but it is experimental at the moment. So this might change in the future. So just be aware of that. Now, moving forward, I want to talk about the actual case syntax. This is the stuff that's fully supported in Ruby and what you'll want to be able to bring into your code today. So the way this works is a case expression like you're always used to. But the subtle change here is that we're not using whens, we're using ins. And that's where we switch to using pattern matching. That's it. That's the subtle change. Now, the one thing you don't want to do, though, is don't mix your conditional logic with your pattern matching logic. Don't put a when in there. That is not syntactically correct. So don't do that. But the thing I want to point out is when you have the case expression in that case and you use your various patterns and ends, it's an exhaustive match. So what Ruby does is it goes through each one of those. And if it gets to the end and it can't find anything, it gives you a no pattern matching error. This is pretty awesome, by the way. I actually really like this. And to explain this better, I kind of need to contrast control flow versus pattern matching flow. So on the left, right, I have control flow, which is your traditional case expression. And on the right, I have pattern matching. Now, what's really interesting about control flow is nothing happens when you get to the end of your last when. What happens in Ruby is it just ends up being a nil. And that's kind of frustrating because nil exceptions are not really fun to deal with within our Ruby code. Now, in the case of pattern matching, though, it'll actually give us the no pattern matching error. And I really, really enjoy this. Now, there's one thing I want to point out. The cool way to change case control flow in Ruby is you can use Rubicop and enable the style missing else cop. As long as you have that set to true, that'll actually give you a linting violation if you don't put an else in your case statements. So I highly recommend turning this on and always making sure that you have an else so that you don't end up in a situation where a sneaky nil shows up in your code and blows up in production or in some other weird way that's hard to debug. Now that we've kind of talked about control flow and standalone syntax, right, let's actually get into the primitives. So with pattern matching, by default in Ruby, you have pattern matching syntax built in automatically for you for arrays, hashes, and structs. So I'm going to dive into each one of those here. And for the majority of this presentation, I'm going to focus on hashes and arrays, but I'll talk about structs at the end. Also, I want to highlight, as I was flashing there with the hash syntax and the array syntax, brackets are optional, brackets and braces, I should say. So you don't actually need those. You can actually strip those off and have a really beautiful, elegant Ruby code that doesn't have a lot of syntactical ceremony. And I really enjoy this. In some cases, though, the syntax for hashes, for braces and brackets are required, and I'll point those out as we get deeper into this. So in this case, I'm just showing here in the top part, right, I'm matching by type. So in my array, I have an array coming in, I'm matching by type. And in the case of the hash, I'm matching by key and type as well. And I'll explain that a little bit more. Now, like I said, this is required for standalone syntax. You can't get away with that. But in the normal case expression type syntax, it's totally fine to leave those as optional. So a couple of few things that I want to point out as we get deeper into this, which is in pattern matching, there's the concept of whole versus partial matching. This is a little subtle, but I'll keep bringing this up as I talk about it deeper into the presentation, because it's really critical in the difference between arrays and hash behavior. So what I mean by that is, in the array here, when this matches, it's going to actually come back as an unmatched, right? It hits the else. And you might be wondering, well, why is that happening? Well, it's because the array in this case has 3 elements in it, but my pattern is only matching for 2 types. So with arrays, it's always whole pattern matching. It's never partial. Now, if we contrast this against Yeah, and the other thing I want to point out is order does matter. So like if you get your elements of your array in the wrong order and your pattern is the opposite, that won't match either. So be very careful about order. That's the one strict thing about arrays is they behave just slightly differently than hashes. Hashes, you have a little bit more flexibility. You can actually have the elements of your hash in any order, and that's totally fine. So the reason the hash matches in this case is because hashes are partial matching by default. That's why I can say, hey, with the key of A and the type of integer, that comes back as a match because hashes are partial by default versus the array, which totally didn't match in that case. So I'll keep explaining this more as we get deeper into this and why this is kind of cool and also has some caveats. So one thing I want to say in terms of caveats here is with hashes, right? There are certain situations in which the partial matching won't work. So on the left here with the with content, I have a hash with 3 elements in it, right? When this matches, it actually comes back unmatched. You might be scratching your head thinking, hey, wait a minute, you just said it was partial matching. Well, the one caveat is in pattern matching with hashes, if you use an empty hash, you actually do want to match strictly on that. And so in this case, it actually comes back unmatched. And that's actually a good thing because you wouldn't have a nice way to match an empty hash any other way if you didn't have this. So that is one caveat to be aware of. Now, in the case on the right-hand side where I have an empty hash coming in, and then I match against that, that totally comes out as a match. So great, that's perfect. Now, switching from hashes for a moment, let me talk a little bit about some of the caveats with arrays. They have a special kind of a set of caveats as well to be aware of. Again, none of this is too terrible. It's just something to kind of be aware of. So I want to point it out to you. I also want to emphasize that this is experimental at the moment because in arrays, since you can't do partial matching, the way to kind of cheat the system and have partial matching is to put finds on the ends. So in this case, what I'm matching against is I have an array coming in. It has 5 elements in it, but what I really care about is just the 2 symbols in the middle. And then using the splat symbols, I'm going to just throw out or just kind of reject the outer edges and match on that. And so this is what I'm matching against in this case. That's how this pattern is going to work. And then when I actually evaluate that, that comes out as a match, which is awesome. Now, the reason I want to point out is this being experimental is this can be really expensive performance-wise. So I just want to be really careful and emphasize that this is an expensive operation. And the reason that is if you have an array of like 1,000 elements or maybe even more, like 100,000, a million, if you're doing the finds on the ends and just throwing everything out, Ruby has to actually parse through all that, right? So if it's a large array, it could actually be really expensive to find these 2 symbols in the middle. So while this is cool, I would use this with a grain of salt and be very careful about this using this in your production code until they fix the performance issues. Now, in terms of finds, you can also name these. Again, remember, this is experimental and this is expensive, but I want to point out that in the first example that I gave you, I was just using splats, right? Because I didn't actually care what they are. But if I did want to care what they are, I could actually give them a name. So I could call them first and last in this case. Then I could spit this out from the command line, and you can see that first gets the first elements in the array, and last gobbles up the last elements in the array, which is just 2 in this case. So that's pretty cool. It's a nice way to actually take your pattern matching, assign it to a local variable temporarily, and then do something interesting with it in your code. And again, I'm just highlighting that these 2 match, right? I'm throwing these 2 elements in first, and I'm throwing this element in the last pattern match there. Okay, so now let's talk about voids a little bit. This is actually kind of a cool sort of interesting feature with hashes that's specific to hashes, not specific to arrays. So when you're pattern matching in hashes, you'll get back the whole matched hash here. And you might be thinking, hey, what's going on? Well, because hashes by default match partially, the way to get hashes to be forced to do a whole pattern match is through the double splat nil void argument. And the reason this is really important, it might be a little subtle and you might be kind of like scratching your head like, wait, hold on, what? Well, what I mean by this is if you just want the whole hash to come in, and if it has anything additional to it, that nil is going to catch it, and it's going to show up as an unmatched situation. So what I'm doing here is I'm just ensuring that the matched whole hash evaluation here that spits out in my console, I'm just ensuring that, hey, if this hash grows to 3 elements or it shrinks to 1 element, that's totally going to end up as an unmatched pattern match. So that's really cool, because without doing the nil void here, like I said, pattern matching in hashes is partial by default. And so this gives us a way to force hashes to be a whole pattern matching. So this is really nice, something to reach for when you actually need that specificity. And so, yeah, just highlighting the nil, the double splat nil in this case is really important for this syntax if you want it to work that way. So let's talk about remainders, right? So this is a little different than the finds that I was talking about before. We're still using a splat and a double splat for hashes. And you can see they're both evaluating here nicely. I'm getting a match in this case. And in the case of a hash, this is just a little redundant because, like I said, we could just not use the double splat and we'd still get a match, right? Because it's partial by default. But in the case of an array, we can kind of take that 3-element array that's coming in. We can throw out through the splat and say, hey, I don't care about anything else. As long as that first position is an integer type, it's totally cool. It's a match. So this is another nice way that is definitely not expensive because it's just at the end of the hash of the array. And we can just throw out everything else and just focus on the types that we care about. So now that we've kind of gone through all of that, let's talk about variable binding for a moment. I've been kind of scratching the surface on this and sort of talking about this, but let me be a little bit more explicit. So in this case, we have an array and a hash. And what I'm doing here is I'm saying, hey, if there's an integer that's coming in the first position, I'm going to call it first. And then for the second, I'm just going to say that it's type integer, and that's totally fine. And then I'm going to spit that out. In this case, it shows up as matched, which is exactly what I want. Now, in the hash case, same syntax here. I'm just kind of showing the different syntax where I have a key and a type. It's just a little different from arrays, but it's the same thing that I'm doing. And in this case, it shows up as matched first in this case too. Match 1, sorry, is the value. So what's really nice about this is I'm just giving the pattern a way to give itself, put the value that I'm matching in that pattern into a variable so that I can actually use that downstream in my program. Now, if I simplify this a little bit further, right, let's say that I don't actually care about the type. Let's say that I only care about position of match. So here's the same code from the previous slide, except this time I've thrown out the types basically. And I've just said, hey, anything in the first position, I'm just going to call it first as a local variable, and then I'm going to print that out to the console. So in this case, when I run that code, right, I get matched 1, perfect. And in the second case, I get the same result, right? Again, it's subtle and just a small breakdown from the previous slide. But if I don't care about type and I only care about position, this is a way to write the same code a little bit more succinctly. So it's really up to you. Sometimes this is really nice to use, and then sometimes it's really important to actually care about not only the position, but the type as well. And again, pattern matching gives you that superpower to do that. Now, when it comes to hashes, there actually is a way to do something a little bit even neater that you can't do in arrays, which is if you don't actually care about the type and you don't actually care about giving it a name, you can just use the key, which is pretty cool. So in this case, right, I'm just gonna say, hey, look, in this pattern for this hash, if the key is called A, and as long as it's in the first position, then that's a match for me. And what I'll do is I'll go ahead and use A as a key to automatically become my local variable. And so I can just spit that out. Again, this is really neat. It gives you a way to, if you like the structure of your hash that's coming in and you don't have any problem with the keys, you can just use those keys as local variables and continue on in your code, which is really neat. The other thing I should point out too is if you don't ever like the keys, it's a nice way to transform your keys. Granted, we have transform keys on hashes today in Ruby, which does the same thing, but it's kind of cool that you can do that in pattern matching too. Okay, so let's talk about nested binding. So if we take this a little bit further, right, now that we understand what's happening with in our patterns, right, in terms of position and type, we can take this a step further and we can actually talk about nested binding. So in this code, right, again, I'm contrasting arrays and hashes again. But in the first, I have to use explicit brackets. So, and the reason I have to use explicit brackets and braces that I wasn't doing before is because when we get into nesting, there's really no way to teach a Ruby, the Ruby parser, what we're doing if we don't actually use explicit brackets and braces. So we have to do that when we're doing nested. So in the first case with the array, right, I'm just saying, hey, look, I've got this array of arrays. As long as the first array has, something, I'm just saying in the first position, and then a type of string, then that's a match. And so in this case, you can see, I don't know if this video stuff is getting in the way for everyone. Let me see if I can minimize. Okay, there we go. What's really cool about this is you'll see that it matches Apple, and it just prints that out in this case. Now, in the second case, again, just hash syntax. I'm just comparing and contrasting arrays, same logic, just different types that we're dealing with. And so in that case, I actually print out Apple as well. Again, I'm plucking it out of the nested array and the nested hash in that case, which is kind of cool. All right, so let's talk about remainders just a little bit. Now, I touched upon this before, right, where I was just doing splat and double splat. But don't forget, you can actually name these. And so I usually just use remainder is kind of my preference, but you can kind of use whatever you want. In the Ruby documentation on this, they call it rest, actually, just a shorter way. Rest is interesting. I like remainder because it actually kind of signifies in the code, like self-documentation wise, exactly what you're doing here with this variable. But what's nice about this is I can gobble up that remainder and I can spit it out into the command line as well. So notice what's happening here in the array. I'm taking first position. I don't care about type again, but I'm putting that into first. And then when I gobble up all the remaining elements in that pattern match, I'm putting it into an array of 2 and 3. So again, really cool because you can use this to do additional things with your remainder values if that makes sense for your code. It's kind of up to you, but at least you have that tool if you need it. Now, in the case of hashes, right, different syntax, right, because we're using double splats, but the concept is the same. So if I print this out in this case, I'm going to get a match of 1, and then my remainder is actually the hash of all the remaining elements in the original hash coming in. So really nice way to gobble that up. Okay, so let's talk about conditionals really quick as well. So one of the cool things in pattern matching is we can actually do conditionals. And the way that we do that is through the pipe operator. So in this case, what I'm matching against is I have an array coming in, right? I have a symbol, I have an integer, and I actually have a float. Now, in the case that the array is all 3 of those things, it's a match, right? Now, what I'm not showing here is I could change that array coming in, and I could just have an array of one single symbol. And if what did come in that way, that would actually be true as well. So what's really interesting about this is you can actually match on 2 different types of structures that are coming in, right? You could have a small array, you could have a large array. And if both of those fit within your realm of what you're looking for, that would turn out to be a match, which is kind of cool, but also be kind of careful because you got to kind of wonder, like, if you're doing things too complex with these conditionals, you might want to simplify your code. So while this is nice to have as a superpower, just be careful that you don't write really complex code because of this. Actually take a step back if your pattern becomes too complex and try to simplify it if you can. Now, in the case of the hash here, I'm showing something a little bit differently where in the array case above, right, I'm just dealing with different types of arrays that have different sizes, basically. But in this situation, notice that I'm actually toggling between a match of a hash, partial match in this case, right? Where if I have an array key and the type integer, hey, that's a match. But if I was to actually pass in an array, that would also be a match. I just want to highlight how powerful that is because I could actually have 2 different types of objects coming in and I could still match against them if I wanted to. Again, be very careful using this in your code, right? Take a step back if this gets too complicated because you don't want to end up writing more complex code even though you have the superpower. So with great power comes great responsibility, I guess. So going into variable binding, right, conditional, we can also bind these. Now, this is something that's specific to hashes, and I just want to point this out as something to have in your back pocket. But oh, I think somebody is.
Sorry
I thought
about
there was
that.
a question. Yeah. No worries. So in hashes, there's something else that we can do. And I want to point this out. It's not something that you should do, because in this case, right, if you just match by the key, and then you do a conditional in an array, this is actually syntactically incorrect. So don't do this. And really you can't anyway, because Ruby's going to give you the syntax error if you do. Now, the way to get around this, though, is you can actually take the A key and actually do it on this side and get a match, because I'm using the underscore, right? Which you're kind of used to in Ruby already, because anytime you have a method or some kind of arguments that coming in that you just don't care about, you want to throw out, you use the underscore. Now, this is meant to signify discarded values only. And the reason I say that, even though this code works, the Ruby team highly recommends that you don't do this, because it's really meant to signify discarded values. It's not necessarily meant for pattern matching, which is technically legal. I mean, the parser won't give you an error on this, but please don't do this in your code, right? Because it's not the actual right way to write a pattern match. So even though it's possible, try not to do it if you can avoid it, because it's really meant to signify discarded values. In the case of writing methods and so forth, it's not really meant for pattern matching. Okay, so I want to talk a little bit about variable pinning as well. I actually think this is really neat, but it's also very subtle and you need to be careful with it. So what I mean by this is, in this case, right, I have, I'm pattern matching in two different situations here. I have a local variable called expectation, and I've set it to the value of 5, right? Now, when I evaluate this down below, notice the subtle difference. In the first piece of code, right, I'm just saying, hey, expectation, if it matches 5, evaluate that for me. In the second case, I've pinned it. And I'll explain what that is, because I need to show what this looks like when I spit out the value. So in the first case, right, this evaluates to match of 1, because expectation is in the first position. So it's going to take the value of 1, and then that's what I'm spitting out. Now, in the second situation, so I'm just highlighting again to emphasize that expectation is pinned to 1 in this case. Now, in this case, though, it comes out as unmatched because it doesn't match at all. And the reason that's happening is because expectation using the caret is pinned to the value of 5. And because value of 5 is not the value of 1 in the first position, it is totally not a match. So that's why it shows up as unmatched. The reason this is important, and I'll explain this a little bit further as we go along, is this gives you a way to basically take a local variable, pin it in your pattern match, and use that for your pattern matching to some really cool effects that you wouldn't be able to do otherwise. So let me explain a little bit further. Let's take something where we're doing variable pinning here again. This time I'm using an array, but let's kind of look at the subtle differences. So in this case, I'm matching the value. So what I'm doing is I'm saying value is the first position, but then I pin this value. So basically, whatever the value of this value is, I know I'm using value really heavily here, but it's really important to show this, which is it comes out as identical because 1 and 1 are the same. Now, in the second case, right, I pin value to value again, but the problem is that value is 1. So the pattern I'm actually matching against is an array of 1 and 1, but the array that came in is 1 and 2. And so they're not the same at all. So let's look at this a little bit more closely. In the first situation, right, value is 1, and then value gets pinned to itself as 1. And so 1 and 1 match. That's why that works. Now, in the second situation, it's the same thing. 1 and 1 are pinned, but the 1 and 2 array that's coming in is not a match. And so that's why they show up as different. Again, really powerful to be able to do variable pinning. But let me take this one step further, and let's actually talk about variable pinning, but let's use it within kind of a more complex pattern, right? Something that's kind of nested. So I hope this helps drive home the point a little bit better, because in this case, right, what I'm going to match against is an ID of 2. Now, the way I do that is I have school coming in, right? I'm just going to use that key, and because the key in my hash is really nicely named, I actually don't need to rename it, so I'll just run with it, which is quite nice. Now, what I'm going to do is I'm going to pin that to school in the subarray of schools, because I have an array of schools here, and I want to pin the value of school so that I can match on that. So the value of school over here is high. That's what's going to be pinned to school over here. And then it's going to match because high in the second element of my array actually has the level that I'm looking for. And so that is totally a match. So, and I spit out the ID in that case, right? So I take the ID and I spit out a match. Now, in the second situation, it doesn't show up as matched. And the reason why is because I'm taking school. Again, it's pinned to high, so the value is high. But the problem is that in my nested array, I only have one element that has middle. And so there is no other school in there that has a high school level. And so that doesn't match. And so that comes out as an unmatched. So again, really cool to be able to have that capability when we're doing pattern matching. So moving away from pinned variables, local variables, and variable binding, I just want to kind of start to wrap up here a little bit in terms of like guard clauses. So guard clauses are just like you've always used in Ruby. It's just that you can use them in pattern matching here. Nothing too terribly special about this. It's just that in this case, right, these both match. And the reason why is because I have an if. And the way and I just want to point out that unless works here as well. But when I assign peach to middle in this case, so because that evaluates to true, that is a pattern match. And same thing for the color black. In the hash down here below, as long as the color that I've not pinned in this case, but just remember that the color in the pattern, right, this key right here, that gives me a local instance variable immediately. And so as long as I can check to see that it has a value of black, then that's totally a match, which is really nice. Okay, so now as we're starting to wrap up here a little bit, I want to talk about, we've talked about hashes, we talked about arrays, but we haven't had a chance to talk about non-primitives and structs. So I want to point out how to make your current code available for pattern matching. And the way that we do that is we define two methods. One is deconstruct. That deconstructs our point class in this case, right, which is just a XY coordinate on a map. We deconstruct it by putting X and Y into an array, and then that gives us a way for Ruby to parse our point custom class through pattern matching. And then in the case of hashes, we just need to define that as a hash. And now we have the ability to automatically pattern match against any of our custom code within our Ruby applications, which is really nice. So whatever you do, don't use these methods for anything other than pattern matching. Otherwise, you'll have problems. So let's look at this code here as I start to use this. Now, we've been talking about arrays and hashes nonstop here for quite a while, but now we can actually use our cool point class and we can match against it. And so I can new it up with a value of a value of 1 and -2. And that comes out as a match, right? Because I don't care what it is in the first position. I only care in the second position that it's an integer. And because those are totally valid, that is a match in this case. And the reason that happens is because I added a deconstruct method to my point class. That gives me the capability to use it in pattern matching. Now, in the case of hash, if I say point new, and then I actually do something a little bit more clever here, where I say, hey, as long as there's a key of X and the value is a range, so basically 0 to an endless range, that's totally a match. And in this case, that comes out as a match as well. So I'm kind of sneaking something in a little bit that we haven't talked about yet, but being able to use ranges like beginless ranges, endless ranges, those totally work in pattern matching as well, which is another superpower that we have. And again, the reason this works is because when the parser, Ruby parser goes through and it parses your class, it says, oh, look, I have a point type, custom type. And by the way, it has a deconstruct keys method. And so if I deconstruct this, I can totally figure out how to do a pattern match on it. Okay, so we've talked about custom classes. Now let me talk about structs just briefly, because structs are one of my favorite constructs in the Ruby language. I think they're kind of underutilized and a lot of people don't know how to use them well. And so I want to kind of highlight just how powerful they are with pattern matching. So in this case, I'm also defining a point, right? Just like our custom class, but I'm going to simplify it and just make it a struct, which actually gives me a whole lot of syntax, a whole lot of capability, but I had to write only one line of code to pull off what I did in the previous slide. And what's nice about this is that we can take that point struct, we can new it up like you see here, we can evaluate it against the type of point and see if it matches. And in case it does, in this case, what I'm doing is I'm saying, hey, the point type, as long as it has a beginless range of 5 being the max, then 1 and 2 totally match in that case, right? The values that are coming in, because it's the same type and it's the same roughly range of values. Now, I want to highlight that the way that this is working is the pattern is point, which is our struct, right, or our custom class in this case, and we can use parentheses and then the pattern that we want to match against. That's basically the syntax. So I'm just trying to highlight that there. It's nothing different than what we've been talking about. It's just a little bit more explicit now that we're dealing with structs or even custom classes. Now, if we take this a little bit further, right, and we say, hey, we have another point coming in, but in this case, I actually don't care about the type. I just care that it basically looks like a range of 5 and 5, then that's going to come back as a match as well. Again, emphasis on type, right? I'm not caring that it's a point type struct in this case. I only care that it actually has an array of roughly those two ranges, 5 and 5. So again, same type as before, but different pattern match. Now, in the second case, this totally doesn't work. And the reason this doesn't show up as shows up as unmatched is because of type. So I have an array 1 and 2 coming in, but I'm trying to match it against the pattern of type point, which is my struct. And even though that would normally be a match if it was just pure arrays, because I've classified that it's a point type, that is not a match. So again, a lot of power in terms of dealing with types of objects and what they consist of within pattern matching. It's a really powerful super feature. So again, wrong type, that doesn't match. So just to kind of briefly emphasize this a little bit further, when we have a struct, right, and we have it come in, the syntax can actually support pattern matching using parentheses. So I'm just highlighting that this is possible as well. Parentheses totally work. Me personally, I like to use brackets, the more array syntax because it really highlights in my mind when I'm reading the code what the difference is between a struct and just a normal class. And so I like using the array brackets, but both are legit. In the Ruby parser, it'll take parentheses or it'll take brackets. So I'm just highlighting that there's a subtle difference in syntax. All right, so let me kind of wrap this up and give some examples, right? I've been talking a whole lot about pattern matching, arrays, structs, custom classes, you name it, right? But let's actually look at some real world uses. So one of my favorite is when it comes to CLIs. I write a lot of CLI gems in Ruby, and one of them is Rubysmith. And what I like about this is in Rubysmith, it's basically a gem for building Ruby projects really quickly with all the default professional tooling that you need to get up and running like really fast. So it's one of my favorite gems that I use for like trying new ideas, spinning up projects really quickly, maybe sharing things with my teammates. Really powerful to get that up and running and have all the stuff I need without having to set it up all myself manually each time. Now, the purpose of this talk is not to get into Rubysmith itself, but I just want to highlight that's what Rubysmith is doing, and I want to show how I'm pulling this off. So, excuse me, don't worry about all the build options in Rubysmith. It actually has a lot of capabilities, but what I want to focus on is just the options that you can give to Rubysmith. So like if you want to build a new gem, you want to look at the Rubysmith configuration, you want to look at help information, or you want to look at version information for Rubysmith. I'm going to show you how I'm dealing with that in the CLI, and it actually takes very little code using pattern matching. So here's the code. Now, the code, I'm going to walk you through this. I truncated some of it, but it's kind of funny. I only truncated it because I wanted it to fit into the slide, but there's actually the things that I cut out are actually not that large. So I'm not actually hiding much here. But let me walk you through it. So what I have is I'm using the command pattern, and I'm saying, hey, look, for my CLI shell, as long as I have an array of arguments coming in, I'm going to parse those. When I parse those, I'm actually going to build a struct. And the struct is going to have certain keys and values in it. Now, you're not seeing how that implementation works, but don't worry about that. It's all about the pattern matching, right, which I've been talking about. And that's the thing I want to focus on. So in the first situation, right, if somebody says, hey, I want to look at the Rubysmith configuration, as long as I have a config of action config, and it is a symbol, then I can spit that into an action local variable and then send that to my config method down here, private method. I fetch these actions. I know this code is off screen, so don't worry about that. But basically, it's just a hash of objects that I want to fetch and then call. Just have them perform the config action in this case. So that's it. That's all I have to do. If the user says, hey, look, I don't care about config, I just want to have Rubysmith build me a new Ruby project, as long as it has the key of build and it's set to true, meaning that the user really wants that, I'll just delegate that to my build method and I'm done. And in the case of version, same thing. I'm just matching for version. As long as it's set to true, I'll go ahead and log that configuration version information to the console for the user, and they'll understand what version of Rubysmith they're running. And lastly, if all else fails, right, they give me some bogus value, something that doesn't match anything I'm looking for, I'll just kindly spit out to the user all the usage options. So in that first screen where I was showing you the usage options for Rubysmith, I just spit that back out to them and say, hey, maybe you meant to do one of these actions, and I'm done. So really powerful in terms of dealing with CLIs. Now, I want to give you another example too, in case you don't care about CLIs. I actually want to talk about a big open source project that I'm working on. I don't have available for code that you can look at yet, but I'm hoping, oh man, I'm hoping within the next couple of months I can kind of get that up, but no promises. But it's called the Janus system. And what's really nice about it is it actually provides a way to automate your deploys through Slack. So I'm using some old syntax here. I'm using a slash command in Slack that is called deployer, but don't worry about that. In the future, it'll be called Janus. But you can see from the help documentation that it actually takes a Slack slash command, parses that information, and then runs whatever command that you want it to do. So in the case of showing the status of your project, totally can do that. I can version your project, and I can give you helpful information, what you're seeing right here. Now, what does this look like when the Janus system actually parses that Slack command, that API request that comes from Slack into my application? Well, the code for that, again, is really simple. So again, I've truncated some code just to keep this slide as small as possible, but you'll notice that the syntax doesn't change that much. So in my case, right, I'm taking the text that's coming from the slash command, and because the slash command are basically space delimited, I just split those, and then I can pattern match on them, which is pretty slick. So in the first case, right, if the person just types the deployer help in Slack, when that message comes in, I split that out. I see that it's just an array with help in it, and I just give them helpful information. I'm done. In the case of status, as long as it's a status and it is a string, I'll go ahead and parse that out, and then I'll just send that to the status private method, which basically just delegates to another object. Again, using the command pattern here, because I'm using call all over the place. And then in the case of version, same thing. I just parse out the version. I grab the string, which is the name of the version that they want. And then I send all that. So name and version in this case get set as parameters to the version method here, and then I just delegate that to that method, to that action. And then finally, if they want to deploy the code into production, I can totally handle that as well. I'll take that deploy, I'll grab the name, I'll grab the version, I'll see if that exists. If it does, I'll go ahead and deploy that code into production for the user, and you're done. You've done everything through Slack, and that's it. And then the last case, right, where I actually don't understand what somebody's trying to tell me through the Slack command, I'll say, hey, sorry, I really don't understand what you're trying to tell me. Try help again to learn more, and then I'll just send that response back to them in Slack. And again, I'm done. So again, this is really nice. I'm using pattern matching in this way to very succinctly break out the various commands that are coming through to me into the Janus system from Slack. And I don't have to write a lot of code to do it, which is really, really nice. Okay, so to wrap up here, there's some guidelines that I've been kind of hinting at, but I want to kind of drive home to help you as you build out your Ruby programs using pattern matching. So the very first tip is, like I said in the beginning, when using arrays, make sure that they're sorted. If you have them out of order, that will make it harder for you to pattern match. So just make sure that the inputs that you're coming in are clean so that you have easy to use patterns to match against. The other thing I want to emphasize, like I said before, is if you're using defined syntax in your pattern matching for arrays, the splats on each side, that is an expensive operation, and it is still experimental. So if you do reach for it, use it with extreme caution. Also, avoid unnecessary deconstruction if you can. So like I was saying, when you have your custom classes, right, and you want to make them so that they're pattern matchable, you add the deconstruct and the deconstruct keys to those objects, right? But don't add them unless you absolutely need them. So wait until you actually have a need to do pattern matching, then add it in. Don't kind of sort of design it up front in hopes that you might use it, because it's just wasted code. And then lastly, shadow variables. In the case where I was showing variable pinning and local variables, it's very easy for your patterns, pattern matching, to actually overwrite a local variable that you didn't intend. So be careful naming your variables really clearly so that you don't accidentally overwrite your local variable, because that can lead to some surprising effects. So just be careful when you do that. And then, lastly, avoid complicated nested patterns, right? Like I highlighted in the screens when I was talking about nested arrays and nested hashes. Just be really careful about nesting those, because that can lead to complex pattern matching and complex code. So try to simplify it if you can before you get to that situation. And that's it. That's kind of pattern matching in a nutshell. I know that's a lot to kind of throw at everyone, but it's a really high level view of what pattern matching looks like, all the ins and outs of it. There's a lot to kind of grok there, and I totally get it. It's one of these things that is really neat, but you do need to sit down and actually take a little bit of time to play around with it. But I think if you spend some time with it and then slowly add it into your code, you'll find that you're actually writing less code, and you can do it a little bit more elegantly using pattern matching. So anyway, I hope you really enjoyed this. It's one of my favorite features that's been added to Ruby lately. And I hope it really becomes useful for your own code as you write your own software. But that's it. That's kind of the end of my presentation. I'm totally happy to take questions and answer any questions that people might have.
Awesome. Thanks, Brooke. I think that was an amazing talk, and also wonderful slides, those animations. I think I'm going to come for classes for the animations. So I don't know if anyone who has a question about what Brooke has spoken about. Just feel free to unmute yourself and just introduce yourself and ask the question. Okay, it seems people are quiet or people float. So did you float or did you get everything? Because the next session, if you didn't understand and you don't have questions, I think I'll win all the prizes. So yeah, or I'll start, I'll just pick someone and I can introduce yourself and just see something. So I'll go with Ian Buru. You can just unmute yourself and ask a question.
Okay, so my name is Ian and I'm from Nairobi. So I've gotten some of that content. I think the main request I would have is how we'd get the slides so that we can look more, especially into the guidelines. Yeah.
Yeah, actually, thanks, Bernard. Bernard actually posted the link in the chat here in Zoom. So if that helps, you can grab all those slides and dive into that as deeply as you want to too.
Thank you.
Awesome. So we can have Felix. If Felix is not ready yet, we can have Philip. I think people are scared.
Yeah, I apologize, Cliff. I hope I didn't terrify everyone. Yeah.
No problem. So I think I'll just pick at least 3 people, and then we can go on to our Kahoot and play a little game. What Brooke has spoken about. So if you don't ask your question right now, I don't think you win the quiz.